Hello, everyone, and welcome back. Today, I'm going to be going over how we can write the explicit rule from the recursive rule. So, first of all, what is the explicit rule? What does that mean? Basically, the explicit rule is a rule that allows us to find the nth term of any arithmetic or geometric sequence just by knowing, in the case of an arithmetic sequence, just by knowing the first term, the common difference, and which term we would like to find. And then for a geometric one, the common ratio, the first term, and then, of course, which term it is we'd like to find. So, the benefit of the explicit rule and why it's called the explicit rule, or the explicit formula in some cases as well, is because we don't need to know the previous term. If I ask you to find let's say, the 1,000th term of an arithmetic sequence, well, that would take you all day with just the recursive rule, because first we have to find the 99th term. And then to find the 99th term, we have to find the 98th term. And to find the 98th term, we have to find the 97th term. And that would, it would take forever to find all these terms just to find the 100th term. Whereas with the explicit formulas, the great thing is that we could just plug in the first term, then the index of the term we're looking to find, and then the common difference or the common ratio, depending on which type it is, and get the answer right away without having to do all this work of finding all these other terms just to find the 100th term or the 1,000th term or whichever term we're being asked for. And so that's the purpose of the explicit rule, and that's why it's it's a useful thing to know. Okay, so let's get into some examples, because that's probably why everyone's here. The first one says to write the explicit rule for each recursive rule. So for this one here, this is an arithmetic sequence. And you can tell because we have the +8 at the end. This tells me that to get any term, we take the previous term and we add 8 to it. So that means the common difference is equal to 8. Also, we can see directly from the formula that A1 is equal to 12. And so there we have it. All right, we can write that the explicit formula is an is equal to 12, the first term, plus n minus 1 times 8 in this case. And there we go. And now from the explicit rule, we can find any term we want. So if we wanted to find the 10th term, we could plug in 10, find the 10th term very quickly without having to find the 9th term first, then the 8th term, and then the 7th term, and so on. We could do that fairly quick. Or if I wanted to find the 100th term, all I have to do is plug in n is equal to 100 and solve this simple equation, and we have our answer. So that's pretty cool. Okay, what about this second one here? It says the first term is 5, and it says that to find the next term, we must multiply the previous term by 2. So that tells me the common ratio is 2. So therefore, the answer it's the first term, 5, times, if we go back up here, r to the power of n minus 1. So the ratio to the power of n minus 1. And now that we have the explicit formula, same thing here. We could plug in any value for n and figure out what the nth term is very quickly and easily without having to find any other terms first. Okay, let's do 2 more examples. This next one is, again, an arithmetic sequence because we are subtracting 4 each time. So therefore, our first term is -3, as it says, and also our common difference is -4. So the answer is -3, which is our first term, plus n minus 1 times the common difference of -4. And so there we go. And then for the last one, we can see that A1 is equal to -8. Let's make that a bit more clear, actually, -8. And our common ratio in this case is -1/2. This must be a geometric sequence because, this must be a geometric sequence because we're multiplying by something, right? Negative a half to get the next number each time. So the answer is first term, negative 8 times the common ratio to the power of n minus 1. And there we go. So there we go. Those are 4 examples of writing the recursive rule, or writing the explicit rule rather, when given the recursive rule.